Hey guys, what we're going to talk about in this video is something called aseptic technique. In other words, how can we manipulate cultures and media, petri dishes, test tubes, etc., without getting them contaminated from the surrounding environment? How can we keep bacteria and molds and viruses even that are in the air from getting into our samples? How can we keep them off our hands, but then also whatever's on our hands naturally, how can we keep that out of our culture as well? Because when we're working with microorganisms, it's usually very critical that we keep the culture pure. If we want to identify the culture, we don't want it mixed. If we're trying to decide its antibiotic susceptibility, we don't want it mixed. It needs to be a pure culture. So how do we keep those pure cultures pure? So I'm going to show you the basic aseptic technique setup, and then I'm going to show you how we apply it to transferring bacteria from a broth culture to a sterile broth in order to encourage growth. Now, at the heart and soul of aseptic technique is the flame. So I'm going to start Bunsen burner here. You're all familiar with Bunsen burners. And I'm going to adjust the oxygen on the Bunsen burner so that I get a nice blue cone, real sharp blue cone on the interior. And that's as hot as it gets. And that's really hot. The tip of that blue cone is around 1100 degrees Celsius. Okay, you can see when I put this little metal wire in there just how orange that gets. Now what I'm holding here, this metal wire, is called an inoculating loop. It's made of a nickel cadmium alloy that heats up really fast and then cools down really fast. And that's important for transferring bacteria around. So what I'm going to do is I'm going to flame the loop, meaning I'm going to put my loop, the wire, in the hottest part of the flame, just above the tip of that inner blue cone. You see how orange it gets? Hopefully you can see that on the camera. If you stick it in there and you go like this and like, oh yeah, look at me flaming the loop, you're not doing anything. You can almost hear the bacteria kind of laughing like, ooh, that tickles. It's not killing anything. It's got to get orange hot for it to die, right? And we're trying to sterilize this. Then I'm going to just patiently, microbiology is all about patience, work my way down the length. And if this loop has been used a bunch today, or if it's been sitting someplace dirty or dusty, I'm going to go ahead and flame it a second time because I'm paranoid and contamination really ruins everything you're doing. But just keep in mind, if it's not orange, you're really not killing anything. And then you notice after it gets out of the flame, it goes back to its natural color again pretty quickly. Now I'm going to set it down next to the flame and let it cool off. It takes about a minute or so for it to cool off. And why did I set it there instead of someplace else? Because this flame is superheating the air around it and above it, and you've got this high pressure zone that's moving out in all directions right here, okay? So this high pressure zone is going to push away any microorganisms from the air, excuse me, that might want to drift in. Now, as I'm talking, as I'm speaking, I'm creating little aerosols that are going to move towards the flame, but they're going to hit resistance and they're going to come back. So not only is the flame useful for directly incinerating and sterilizing tools, it also creates a little safe space. I call this the safety zone. It's roughly a radius of about a foot all the way around the circle, which means I've got a place that I can work where my stuff isn't going to get contaminated from microbes from the air. So now all the manipulations I'm going to do within that safety zone around the flame. Okay, so that's probably cooled off. The next thing I want to do is I want to show you, hopefully we can zoom in on this, what it looks like when bacteria have grown in a broth. In my right hand, your left side, you can see sterile LB broth. LB is just one of the common broths that we use to culture microorganisms. It's got kind of a golden color to it, but it's clear, right? There's no turbidity or cloudiness to it. Over here in my left hand, your right side, we inoculated this last night, meaning we intentionally added some bacteria, in this case E. coli, and overnight you can see just how turbid or cloudy this got. And when the two are right next to each other, hopefully you can see the difference in bacterial growth. So here's a sterile tube, and here's a tube that has bacteria in it. Now, when we want to ask questions about bacteria, when we want to study them, we have to grow them or culture them. And so we're constantly inoculating. So if I've got a source culture like this, and I'm ready to run a test of some kind, I'm going to transfer bacteria using that inoculating loop that I showed you a minute ago that's now sterile. I'm going to transfer a loop full. Now, what will cling to the surface of that loop is about 10 microliters. And from a dense culture like this one here, this culture has about 1 million to 10 million bacteria per milliliter. which means in that 10 microliter shot, we're looking at tens of thousands of bacteria. Lots and lots of bacteria, plenty to start a new culture. So the way I'm gonna do this, I'm gonna hold in my right hand, because I'm right-handed, just hold in your dominant hand, your tool, in this case your inoculating loop. And you wanna hold it way down at the end here, it's not a pencil, so you're not trying to hold it down here, you're gonna burn your hand. It's not a knife, you're not trying to hold up a 7-Eleven here. Hold it more like a paintbrush, way down at the end. With the same hand, you're gonna remove the cap. Now you notice I'm close to the flame, I'm in that safety zone. So I'm gonna remove the cap in the safety zone, and then I'm gonna immediately flame the lip of the tube for about a second or two. The tube is glass, which means I can superheat the glass and kill anything that got up and under the cap, but then it also creates a column of hot air right here inside the tube that'll continue to slowly but surely push up and out. So I've got my safety zone from my flame, and I also have a column of hot air right here inside the tube that I just created. When I flame the lip of a tube, I consider that a pretty safe environment for about a minute. If you're gonna work with it open for more than a minute, you'll wanna flame it again just to make sure you keep things good and hot and you keep that pressure coming out. Now I'm gonna take my sterile loop, I'm gonna reach down into the broth, and I'm just gonna come right back out again. This is like those bubble wands you used to have when you were a kid, and you just get a little film, but you don't want it to pop. I'm gonna flame my glass tube one more time, carefully set a cap on it, and then set it down. Now I'm gonna take my sterile tube that I'm transferring to, take the cap off, flame the lip, put my loop down in there and rattle it around a little bit, flame it again, cap it, and set it down and let everything cool off. Now I'm not done, because now my loop is contaminated with E. coli, so I'm going to flame this a couple of times to make sure I kill everything. So I'm gonna I like to start down here at the end where the bacteria just were, and then start again way down at the base. Not likely the base got contaminated, but let's not take any chances. Work my way all the way down a second time. Once that's done, I can set it down carefully within the safety zone to let everything cool off. And now I've got a tube that has a handful of bacteria. It doesn't take much, a few thousand E. coli in here. If I warm these up in an incubator overnight, by morning they're gonna look exactly like this one here. You're gonna have millions of bacteria, tens of millions per milliliter as they cultivate and grow. This is a really essential technique, inoculating broths and using and applying your aseptic technique. So in later videos, we're gonna look at some more high level, if you will, applications of aseptic technique and inoculations. Thanks for listening.